My name is Stephen Platt. I'm with North Idaho College's Medical Lab Technology program. And today I want to talk about our automated hematology analyzer. And we use this for automated CBCs and automated differentials in our classroom laboratory. Some things I want to go over today is our daily routine for how we start up our analyzer and some just general maintenance that we like to do to make sure it's passing startups consistently. So the first thing we want to do after we start the analyzer and turn on the software is go into the program. It's going to start on run. We want to go to work list and we want to go file, new work list, to start a new work list for the day. And what that does is that if you start a new work list every day, then it archives all the information and all the samples that you've run day by day. And this makes it a lot easier to go back and search through old samples in case you ever needed to get information from a previous day. And another thing this does is makes the software run a lot more smoothly. So after we've done file, new work list, we can go down to startup right here. And now the startup will take a few minutes, and so I'll pause the video and we'll come back after the startup is complete. So our startup is complete. So to verify that our startup has passed, we'll come up here and use this menu bar up top. We'll go over to the Logs tab, and over on the left in the Logs menu section, we can click on Startup. And we'll scroll all the way down to the bottom to the most recent startup, and that is 2/27/2020. You want to verify that it's the correct date and correct time, that this is indeed the startup that you ran. And if it passed, you'll see that it says done right here. And then on February 10th, you can see that the startup failed. So you want to look for done. So we see done, and we can see that our startup today has passed. So now that our startup has passed, the next thing we want to do before we can run patient samples for the day is run our controls. So to do that, we want to go to this QC and Calibration tab. And in this tab, there's a few things I want to show you. In this little drop-down menu right here, you can pick which control you're going to use, and you want to verify it with the lot number of the controls your facility is using. And something I want to show you is in this one. So in this control, we can see that these numbers are red, and what that means that these values for hematocrit and mean cell volume are too high. Now if you run a control and the values are too high, there's some things you can do. First thing you can do is remix the sample and try it again, because these controls tend to be finicky, and we want to ensure that the control is mixed properly. But if you run it again and you're still getting red, there's some maintenance steps that we're going to go over in a bit that we can try to troubleshoot these issues. Now in our lab, we use the Hariba Difftrol low, normal, and high controls. So in order to make sure these controls are well mixed, you want to make sure they're sitting out for 15 minutes, which they have been. And according to the package insert, you want to keep it horizontal and roll it in between your hands for 15 to 30 seconds, which I've already done, so I'm not going to do it again now. And then invert it 8 to 10 times. And what you're looking for is you want to make sure that the sample just appears to be well mixed. And these should be very similar looking to normal whole blood. So after you're confident that the control is well mixed, you want to come to the drop-down menu that I showed you before, pick the correct control, make sure it's the same one. You want to look at the lot number, and the one I'm looking at is PX421L. And so I see PX421L in that menu. And then after that's selected and it's mixed, you stick it into the slot and just close it and run. Now what I wanted to show you here is hopefully something that doesn't happen very often, but in the case it does, you see an error that says rejected result not recorded. Now sometimes the analyzer and the computer software have trouble communicating with each other. And then when that happens, you can just press OK and run the result again, or run the sample again. Because if the result's not recorded, then, it never happened. But if it keeps happening, how do we fix that? Well, unfortunately, we have to turn the software off, turn the computer off, let it be off for a minute, run the shutdown on the analyzer, basically just turn everything off and then turn it back up again, run through the startup and start the results again, because there's really not any other way to kind of get that connection to be made again. So I've run all three controls, but after we run the control, we can come down to this menu and we want to scroll across and see that all the values are within range. And you'll see blue if it's too low, red or if it's too high. And you can come down to this menu and here's all the calculated values for all of the controls that have been run for this specific level. And you can see the mean, the target diff, the standard deviation, and the coefficient of variation. So we can go to the next control, the normal. And on this one, you can see that this value is too high. And so what I did was I remixed it, ran it again, and now we can see that everything is good to go. And that just goes to show that make sure your samples are very well mixed. And you can come right here and you can just uncheck that value for the one that we don't want. And so what this is doing is it's changing the calculation, so it's not including that result in these calculations, but it's still recorded within the system. So when you go into the Levy-Jennings chart and for hematocrit, which is the value that was too high, and you can see, so it's not deleting that result. All we want to do is just keep that result out of the calculations for here, because we want to see these calculated values for everything that we like. So we're using this one for today. So now we'll go to the high control, and we can see that everything is within range. And so now we've run all three controls, and they've all passed. So now we're ready, if this is a real lab, to run patient samples for the day. Now let's say our startup didn't pass, and according to the user manual, the first thing we want to do is check the reagents to see if they are expired. Now this is a student lab, and it's a reality of ours that our reagents get donated to us, and we don't normally get reagents donated that are not expired. So in our case, our reagents are expired, and you can open the door right here and you can check them, and they should be set up in a way where you can see the dates and the expiration in a lot. Ours are expired, but we're going to go ahead and pretend that they're not expired and that's not the issue. So the next step, according to the user manual, is to do a concentrated cleaning. Now to do a concentrated cleaning, we're going to go up to Service in the menu tab up here. We're going to go to Hydraulic Systems, Cleaning Cycles, and Concentrated Cleaning. And you want to click that first. and click OK. Leave a comment if you need to. We're not going to leave a comment today. And we're going to let that run for a minute until this next little menu pops up. Now when this menu pops up, you do not want to press OK until you've done this. You want to pour 3 milliliters of Minoclair into the chambers, press the enter key to continue. Now I'm going to show you what it means by that. So now we're going to open up the side panel. And then we can see these chambers that they're talking about. So we want to pour 3 milliliters of Minoclair into each of these chambers right here, into these 5 chambers. And then right here you can see there's a key that says what these chambers are used for. And I'm going to go ahead and do that. Now we're using the ABX Pentra. We're going to use just a pipette and make sure you get it into the chamber and fill each of the 5 up. And these pipettes, they should take about 2.5. Now after those are filled, you can go ahead and close the side panel and go and click OK in the menu. So now that we've filled the chambers, come back, click OK, and the cycle will complete. And it will tell you when it's done, and you can just click close. The last thing I wanted to show you today is how to run a patient sample. So we've done our QC and it passed. We did our startup and our concentrated cleaning and everything is good. So that means we can run our patient samples. So we're going to come up to this menu bar. We're going to go to Run. We're going to come down here to this second window. And if you're lucky enough to have barcodes, then just use this. Scan your sample. But since we don't have barcodes, we're going to type it in. And so we're just going to type in your sample ID, type in your patient name, and press enter. And then we're going to come over here, put the sample in, and run. So I hope this video was helpful in getting you familiarized with the Horiba ABX Pentra 60C Plus and showing you the most common things that we'd be doing in our lab. And the last thing I want to leave you with is the user manual. So within the software, if you click up right here, the user manual pops up. And I know I probably did the world's most wonderful job in showing you everything you need to see, but the reality is I can't be as good as what the user manual will show you. And so if you open this up, you can navigate through going into quality assurance, maintenance and troubleshooting, specifications, and go to the information that you need at your specific time. And if you're a MLT student watching this, I can't help but stress description and technology. So this goes over how the analyzer works. For example, how it measures your RBCs and how it measures your platelets. And I think that's really valuable information to know as a student. So thank you for watching.